Hey guys, welcome to my new channel. Today we are going to solve the coding question which is commonly asked across different technical interviews and across multiple companies as well. Uh, the name of this problem is two sum numbers. Basically, as a part of this problem, we will get two inputs. The first input is an array which will contain non uh, empty and distinctive integers, and the second input is the target sum. And as a part of the problem statement, the task for us here is to find a pair of integers in the array whose addition or sum would be the target sum, which will have either a positive or a negative number. So, for example, in this case, the target sum is 10, which means that we need to find the pair of integers in the array whose addition or sum would be 10. For example, in this case, it should be 11 and minus 1. And there could be multiple solutions for this. For example, let's say there are like other integers as well. In this example, we have only one solution, but there could be several different pair of integers whose addition would would match with the target sum that is passed as an input. So, how do we approach this problem? First, we'll discuss the brute force technique. Basically, in brute force technique, what we'll see is that we will have two loops, and as a part of loop operation, you will traverse each and element in an array. So we'll have outer loop and we will have an inner loop. So in the outer loop, you will start with the first element in an array, yeah, which is 3. And in the inner loop, you'll start with the remaining set of elements starting with the next element of the outer loop. In this case, it starts with 5 and it ends with 6. Yeah. So in the inner loop, if I start with the element 5 and check if the addition or the sum of the outer loop element and the inner loop element is equal to 10, which is not. So in the inner loop, I'll move on to the next element, which is minus 4. And this addition also is not resulting into the target sum. So in the inner loop, I'll traverse till the end of the array and I'll find that there is no element which is satisfying the condition where it's the addition of which with the outer loop element is not coming to 10. So in once I exhaust all my iteration in the inner loop, in the outer loop I'll move on to the next element, which is 5, and in the inner loop I'll start with the next subsequent element and I'll iterate till the end of the array. So I'll start with minus 4, which is not the which is not equal to 10, and 8. 5 plus 8 is 13, which is not equal to 10. And I'll come till the end of this element of this array and realize that there are no elements which match the condition where the sum is equal to 10. So I'll perform the same iteration like for the outer loop, starting for minus 4, and the inner loop will start with 8, 11, 1, minus 1 and 6, and all these elements do not satisfy the condition. And finally, when I encounter the 11, the inner loop starts with 1, and 11 plus 1 is 12, which is not true. And when it comes, the pointer goes to the next element, which is minus 1. 11 and minus 1 result in 10. So I return my result as 11 and minus 1. So these two pair of elements in an array form the addition of these two elements will form the target sum. So how do I, code this uh, in my function? So in this case, I'm using Jupyter Notebook. You can use any editor of your choice where you are comfortable. So let's try to code this in our function. So as I mentioned, we'll have two for loops. One is the outer loop and the next one is the inner loop. So let's start with the outer loop where I'll start with the first element in an array. So for I in array, which represents each element in an array, starting with the element in the at the index 0. And in the inner loop, I'll start with the next element of the outer loop element. Let's say for j in, I'll use the index function in Python to get the index of the next element in an array. Yeah, I'll start with array dot index of I, which will get me the index of the first the element which is considered in the outer loop, and I'll start with the next element in the inner loop. So I'll just use the array slicing technique here. So this statement will start traversing in the traversing the array with the subsequent remaining subsequent or remaining set of elements. Uh, for example, if I'm starting with 3 in the outer loop and in the inner loop, I'll start with the 5 and I'll traverse till the end of the array. And the condition that I'm checking here is if these two elements in the outer and inner loop are adding up to, let's put this if statement, are adding up to target sum, then I'll return these two in the form of arrays. And if all the iterations are exhausted in an array, then uh, it implies that there is no matching pair, and hence I'll return the empty set or empty array in this case. So my function is complete. Let me try to execute this function using a test data. I'll call my function. I'll pass a simple array here, 1, 2, 3, 4, and 5. And the target sum I'll pass as 7. Let's see if I get the correct result here. Yeah, as you can see, there are basically two solutions for this input, right? You can have either 2 and 5, or you can also have either 3 and 4. Here the ordering does not matter. You can have 4 3 5 2 as well. But since we are traversing from left to right, starting from index 0 till the end of the array, hence, the first encounter of this solution is when the outer loop is 2 and the inner loop, reaches the element 5 and it satisfies this condition. So this approach will definitely give you the right solution, but the question here is it the most optimized solution? As we can see, there are two for loops involved here, and that if you actually calculate the time complexity, it would result in the function of big O of n square, because in the worst case scenario, you may have to traverse all the elements in both inner and outer loop as well. So what is the most, so do you think there is an optimized solution for this? Let's try to solve this uh, within the bound of big O of n. So let's go back to the problem statement. Basically, we can we can traverse the entire array only once and try to find if uh, if there exists a pair whose addition would result in the target sum. So for this, we can make use of hash map, or you can make use of arrays itself, but there is an additional data structure involved here. So what this solution uh, proposes is, for each element that you traverse in this array, if you will try to see if there already exists a previous the previously traversed element in your dictionary or a list. For example, if I'm starting with number 3 here, and I have this empty dictionary or empty list in as a data structure in my solution, and once you see 3, there does not exist anything. So what I'll do is I'll insert 3 here as my first element in this list or a hash map. When I go to 5, I'll check if the difference of this target sum and this current element 10 minus 5, which is 5, already exists in this list. If it does not exist, then I'll enter this element which is there, which is currently being traversed. And when I go to the number minus 4, I'll see the difference between 10 and minus 4, which is 14. So it does not exist here. So I'll enter minus 4. Let me try rewrite this list so that all elements are covered. And when the control comes to 8, the condition here checks the check condition that we are trying to do here is target sum minus current element 10 minus 8, which is 2, which is not present here. So I'll enter this element as well in my hash map, or you can use list as well. And when it comes to the element 11, and we'll see if target sum minus this element 11 exists in our list, which is 10 minus 11 is minus 1, so it does not exist. So I'll enter this as well. And when it comes to the next element, which is 1, so the target sum minus 1 is 9, it does not exist, so I'll enter 1 as well. And when it finally comes to minus 1, the target sum minus 1 is 11, which exists in our list or dictionary structure. So what we'll do is we'll return this pair in any order. It could be 11 minus 1 or minus 1 11. So let us try to code this in our solution as well. So I'll rewrite or create a new function. Let's say def define and I'll have the same inputs. I'll just copy this. So first, as a first step, we'll define a new data structure, which is dictionary or hash table, which will contain key value pairs in Python. So let me try to define an empty dictionary here. So we'll traverse each and element in our array. Let's use for loop. and we will check if the sum minus the target sum minus the current element already exists in our empty dictionary. If it exists, then we'll return the elements. Else, we will append this current element in our empty dictionary. You can actually add, use the append statement, or you can also uh, directly add this element with the value, with the key value in the form of key value pair where, we are setting this value to true. So let me, if we exhaust all the elements in the list and do not find the matching pair, then we'll return the empty array. So this is the function is complete. Let us try to pass the same input by changing the function name. As you can see, we get the uh, solution here, which is 4 and 3. But if you actually see the time complexity of this, we are only traversing this array once uh, because we are not reaching till the end of the array. We found the solution in the middle. So the time complexity of this is big O of n, and the space complexity, since we are using an additional data structure, then the space complexity is big O of n compared to the above solution, which is big O of 1 because we are not using an additional data structure. So in the optimized approach, we saw that the time complexity is improved by a huge margin because we are not traversing this array over and over again. It's just in the worst case scenario, we are traversing all the elements in the array. But as you can see in this input, we are not traversing all the elements. We have found out the solution in the middle as well. So this is the optimized approach and also the recommended approach to solve this problem. I hope this solution is helpful, and we'll see you in the next video.